Welcome back to 30 Days of Physics with Miss B, and we're moving right along with matter. Matter is any and everything that has mass and takes up space. Matter is made up of particles. Matter exists in three distinct states: solids, liquids, and gases. The particulate theory of matter states that all matter is made up of particles, and the particles either vibrate or move from place to place. Attractive and repulsive forces exist between the particles, and the particles that make up matter can be atoms, ions, or molecules. So what are particles? Particles may be atoms, ions, or molecules. There are 100 plus atoms which combine in many different ways to make lots and lots of different types of molecules and ions. So what's an atom? An atom is the smallest particle known to man that can exhibit the qualities of the element it originated from. It cannot be broken down by chemical means, and it comprises of protons, neutrons, and electrons. A molecule is a particle that contains one type or different types of atoms. In the case of carbon dioxide, it contains both carbon and oxygen atoms. In the case of methane, it contains both carbon and hydrogen atoms. And in the case of hydrogen, it only contains hydrogen atoms. When a molecule contains the same types of atoms, it is referred to as an element. For example, oxygen, hydrogen, and chlorine. All of them each contain only one type of atom. Chlorine gas contains only chlorine atoms. Oxygen gas contains only oxygen atoms, and hydrogen gas contains only hydrogen atoms. When the molecule contains different types of atoms, it is referred to as a compound. For example, water and carbon dioxide. Carbon dioxide contains only carbon and oxygen atoms, whereas water contains only hydrogen and oxygen atoms. What's an ion? An ion is an atom or group of atoms with either a positive or negative charge. Positive ions are referred to as cations, and negative ions are referred to as anions. Examples of ions are the sodium ion, which is known as a cation, the oxygen ion, which is known as the anion, and the nitrate ion, which is known as a polyatomic anion. A polyatomic ion can be positive or negative. They are composed of more than one atom. Arrangement of particles in solids. The particles in solids are arranged very closely. They have a regular pattern, and the particles vibrate around a fixed point but do not move from place to place. The attractive force between particles is strong, and solids cannot be compressed. Arrangement of particles in a liquid. The particles of liquids are arranged very closely. They have an irregular pattern, and the particles translate or slide over each other slowly. The attractive force between particles are weaker than those in a solid but stronger than those in a gas. Liquids cannot be compressed. Arrangement of particles in a gas. The particles are arranged very far apart. They have an irregular pattern, and the particles translate or move everywhere rapidly. There are almost no attractive forces between the particles, and gases can be compressed. The difference between Newtonian and Non-Newtonian fluids. Most fluids are Newtonian. They can be categorized as liquids or gases. This is because they have constant viscosity due to pressure or force applied to them at room temperature. While non-Newtonian fluids, however, are substances that do not fall into being either a liquid or gas. They do not behave like we expect them to. The viscosity of a non-Newtonian fluid flows at a different flow rate depending on how much force or pressure is applied to them at room temperature. An example of a non-Newtonian fluid is oobleck. It is made by mixing some cornstarch with water. When pressure is not applied to it, it behaves like a liquid. However, when pressure is applied to it, it behaves like a solid. Transitioning. Solids, liquids, and gases are able to transition from state to state depending on the temperature and pressure applied to them. Substances either melt or evaporate when heat is applied, but when heat is removed, they either condense or freeze. When a solid becomes a liquid, it melts. When that liquid transitions into a gas, it evaporates. When the gas transitions back into a liquid, it's said to condense. And when that liquid transitions back into being a solid, it freezes. Sometimes solids can skip the liquid phase and move right into the gaseous phase, and that is known as sublimation. Expansion. When heat is applied to solids, liquids, and gases, they expand. This expansion causes bonds to break as the heat energy supply converts the kinetic energy of the particles. Science uses expansion to its advantage. For example, the liquid inside of a thermometer expands when heat is applied. That liquid may be mercury or alcohol. A bimetallic strip consists of two metal strips riveted together. Bimetallic strips are often used in nifty devices such as fire alarms and thermostats. One of the metals expands more than the other when it is heated. In the picture above, brass is a better conductor of heat than invar. Bimetallic strips. Bimetallic strips are used to make circuits smart. They complete circuits by responding to heat. They are placed in simple fire alarms. When the bimetallic strip gets hot from the fire, they bend upwards and close the circuit, which causes the alarm to go off. They bend upwards because brass expands more than invar when it is heated. Bimetallic strips are also placed in thermostats. Thermostats are used to control temperatures in ovens, refrigerators, and irons. Sometimes expansion of substances can cause problems. Streets made of concrete are made into slabs and padded with pitch. When it gets really hot, concrete cracks. To stop the formation of long cracks, the pitch expands to allow the concrete to move freely. Power lines are laid slack so that when hot temperature becomes cold, they would have the ability to contract without bursting. Alright guys, thanks for watching another session of 30 Days with Physics with Miss B. See you tomorrow for day 15. Bye!